Hello, Amnon. Thank you for joining Next Wave.
Thank you, Young. Happy to see you, even though it's remotely, but it's always a pleasure to see you.
So MobileEye, which is one of the pioneers, company really drove the whole concept of a safer driving and enable people to think possibility of autonomous driving. And I know you've been involved in this for a long time. I've been in your car already several years ago, and I remember test driving and what the possibility is. So maybe you can give a perspective of where it had been in terms of a MobileEye journey and where we are today and where we are going.
Well, first, I invite you again to come and drive our test cars. It's really magical the way these cars handle themselves. Now, I think one needs to take a step back and just understand what is the nature of this challenge. And then if you look at products today, there are two types of products. One family of product is very, very sophisticated from a technological point of view, but low accuracy. Means they can fail often and it's fine, like a PC, like a smartphone. These are very, very sophisticated engines and products, especially from a software, hardware, embedded point of view, but they can fail and it's okay if they fail. The second family of products are not so much sophisticated, but very accurate. Means they fail rarely. And an airplane is an example of such a product. Now, the tolerance for failure is basically zero, and it's not that sophisticated. The aerodynamics are things that are known for more than a century. Autonomous driving is both. You have to be very, very sophisticated. We're talking about cutting-edge silicon, cutting-edge software, cutting-edge data-driven algorithms, cutting-edge AI. So very, very sophisticated, but on the other hand, very, very accurate. The tolerance for failure is almost zero. And then this is where the conundrum, this is where the big challenge is. So we are kind of building this in several layers. The first layer is defining what is the mean time between failure. What makes sense in terms of an MTBF of a perception system? What makes sense of an MTBF of a decision-making process? You decided to change lane and you did it in a not a safe manner, and there's an accident. What is the probability of something like this happening? So we develop technologies around it. One of them is RSS, Responsibility Sensitive Safety, which attempts to standardize the decision-making process of a robotic engine and reach consensus with regulatory bodies in terms of how do you define the border between recklessness and carefulness. And once a robotic engine knows what it means to be careful, it can then follow this consistently. So this is one big challenge. Another one is to define the mean time between failure and a perception system, and we do that through redundancy. So we build redundant systems. So for example, at MobileEye, we have a subsystem of only cameras, just cameras doing an end-to-end experience of autonomous driving. And then we have a separate system, just radars and lidars, doing an end-to-end, no cameras at all, doing an end-to-end, and then bind them in order to reach a very redundant and very, very low mean time between failure. Second challenge is scalability. Now, eventually, the holy grail of autonomous driving is consumer level, where you buy a car, pay an option price of a few thousands of dollars, and then whenever you want, you sit in the back seat or you go to sleep. For this, you need scalability. You need to be able to drive everywhere. And one of the limiting factors in this is maps, high definition maps. So we have a technology, crowdsourced technology, in which many of our production vehicles from many of our OEM partners are sending data to the cloud, and we build high definition maps. Just recently, we launched a test site in Munich, where with 5,000 kilometers of roads being mapped completely automatically, just through crowdsourced data. And we have our customers, like car makers, go and test this car, and it's really magical. Third one is regulation. Accidents will happen. No matter what you do, accidents will happen. And then the question is how is this going to be handled from a regulatory point of view? There's criminal liability, there's financial liability. One needs regulatory certainty. in this area. And this is also an area that we're very active, working with regulatory bodies around the globe in order to reach a consensus of a regulatory certainty in order to enable autonomous driving. This is a major point. And the fourth and last challenge is, how do you build a business, a viable business, when you're talking about a development that could take many years? And luckily for MobileEye, we have driving assist as a spectrum. So we are building the technology combining both driving assist, which generates the money, and autonomous driving, and technology which we develop for autonomous driving trickles down to driving assist. Recently, we announced with the Geely in China a system we call Supervision, which would be launched next year, August, September next year in China, which with 11 cameras around the car, 2 IQ5s, which is basically productizing our camera subsystem of our AV development. So this allows us also to generate a business by influencing the evolution of driving assist to more and more advanced driving assist while we're developing autonomous driving.
It's great. I mean, it's as an engineer, the car is really becoming a supercomputer with a sensors that are built in. In this case, would be cameras, obviously, but also radars for the days where you cannot see things with the camera, and augmenting each other, and then being able to give you the range and the possibilities, and being able to object detect and what's out there. Let's talk about a little bit of the work. I believe you're working in Israel and others. This whole concept of Robotaxi. Do you see Robotaxi coming next few years, or do you think this is concept?
So the first, the place of Robotaxi in kind of this long vision, we see Robotaxi as a step along the way for a consumer autonomous car. It's a step because there are certain limitations that are very helpful. One is that the tolerance for cost is not that high. You can put a system that costs, say, tens of thousands of dollars in a car, and it's still viable from a business perspective if you are shuttling people like a ride hailing and ride sharing. Second is scalability. You don't need to drive everywhere. You can drive in geofenced areas. Describe a polygon of, say, 100 kilometers square, and you provide a Robotaxi service only in that polygon. It still makes sense from a business perspective. And third, from a regulatory point of view, it's easier because you are regulating a fleet and not a consumer. So regulating a fleet, there are all sorts of reporting responsibilities, back-end, teleoperations, all sorts of things that the regulator can put on a fleet. And it's very difficult to put on a consumer product. So this is why Robotaxi seems like a very attractive step, because it can build its own business, ride hailing and ride sharing by removing the driver and saving about 85% of the operating costs of today's ride hailing and ride sharing. And it's a corridor to eventually reach a consumer level product in which you and I can buy a car, a few thousands of dollars extra option, maybe if it's even $10,000. For a few thousands of dollars, buy a car and whatever you want, sit in the back seat. But we believe that to get to that point, Robotaxi is a very useful and advantageous step. So we are building that capability. For that reason, we also purchased MoveIt half a year ago. At the heart of the pandemic, we purchased MoveIt, and together with MoveIt, we're building this end-to-end. MobileEye is building the self-driving system, self-driving vehicle, and then MoveIt is building all the remaining layers from the customer experience, fleet optimization, mobility intelligence, in order to provide a service. And we're going to, we have regulatory support in Israel. We're working on regulatory support also in other places. And we believe that 2022, we can start removing the drivers from a fleet of about 100 vehicles in Tel Aviv.
Wow. So this is really a mobility as a service in a way, because Robotaxi is enabling, let's say, enabling tour, but also you're adding the applications and management tools on the top of it so that you can be able to provide end-to-end experience as a way to improve the capabilities and also testing the possibilities of removing the most expensive part of the Uber economy, I guess. Now, are you thinking MobileEye as a technology enabler, or are you thinking of actually going all the way to end-to-end service?
No, we are building all the way end to end, but then we'll make a decision at the appropriate time what to license, where to partner, what to do end to end all ourselves. But the technology will be built end to end, including the customer experience. And then through partnerships and licensing, we can then extend this from a business perspective in a way that makes sense, kind of reaching a right balance between capital and partnerships.
Very interesting. I'm going to watch this one very carefully. Let's talk about another subject. I'd like to get your perspective about where is your Orcam, where is it going?
We founded the company back in 2010 with my partner, Ziv Aviram. I think both MobileEye and Orcam is looking at AI at the edge, right? So MobileEye, all the AI is being computed in real time in the car, not in the cloud. The same thing with Orcam. The vision is to build a wearable technology. That means AI on you, whether on your eyeglass or on your shirt. And this AI both sees and listens to whatever you see and all the acoustics around you, and tries to provide you value. So the question is, what is this value? So we kind of decided to take society and peel it layer by layer. So we said, what would be the first layer of society that if you had a device that can see and interpret the visual world, it will provide you immense value? Then it's blind people and visually impaired, they don't see or they don't see well. And if you have a device that sees what you cannot see and then whispers in your ear what you are seeing there, it could be of great value. And this is where we started. Today, this device, it clips onto eyeglasses, and we also have a version it's handheld, scans the visual world, understands everything, understands about objects, about faces, about text. It knows how to lay out the text. If you're holding a newspaper, it knows where are the titles, how the articles are laid out, and so forth. Of course, it can read to you. It will understand hand gestures in order to understand what you want from the scene, and it will also understand your voice. You can ask it questions. For example, you can open a newspaper and ask the device, read me the headlines. And within a fraction of a second, you'll start getting all the headlines. And then you can say, stop, read me article number 3. And then it will start reading article number 3. If there's a person in front of you, it'll tell you who that person is. If it's a product, money note, it'll tell you who it is. If you ask what's in front of me, it will tell you every object that is in front of you, and then you can ask it, guide me to that object. It's really trying to take computer vision and natural language processing, put them together, and provide an experience to someone who doesn't see, that it will not regain his sight, but at least it will be able to cope with the visual world. The next thing that we have been doing, we are going to launch early January, a product that we unveiled last CES. It's really magical. The idea is it's called the cocktail party problem, helping people that have hearing disabilities or even mild hearing disabilities. The idea is that if you have many people in front of you talking at the same time, like when you're at a restaurant situation, lots of noise, lots of people talking, what a device like this can do, where you have a camera and you have a microphone and you have compute, it will lock on to the lip movement of the person in front of you and then tune in only to the voice of that person and kind of remove everything else. Once you try it, it's really magical.
Sounds like James Bond experience. This is a very interesting technology that can augment and supplement a lot of people. As people are getting older, their memory is getting impaired or decreasing. And so it could be very interesting supplementary products that can help people's memory and being able to realize the context. But at the same time, I would imagine people are worried about privacy of their data. So it's a question of privacy must be very interesting issues that have to manage in this particular category of products.
Yeah, so privacy was really a killer. So we did experiment with a technology with technology, which is, the purpose is not to help people with disabilities. It is to recognize faces, just recognize faces. And this is, I think, what Daniel had showed you. We put it on Kickstarter. We shipped 1,000 such devices to kind of test, how it is accepted by the public. And the device really, from a technological point of view, works really well. It learns faces of people that you see. Of course, those faces are stored in the cloud, but the privacy issue really killed it. People are not comfortable with this kind of what appears like lack of privacy. So this is why we didn't push this product into mass volume, and instead we focused on, let's help people with hearing disabilities. Here, there's no communication with the cloud. Everything is done on the device. There's no privacy issue.
Azure devices that are helping people to live better, actually, and helping them to have a sight they may not be able to have using cameras and being able to using mics. It's a very interesting innovation, and I'd like to get a sample and try that out as just a way to learn more about it. But that is very impressive. I have a question around the changing subject to now big company. So clearly, I used to work at Intel as my first job, actually, after college. It's been a great experience and great company. But the question for you is that you are very fast-moving, hard-charging startup entrepreneur that believe in revolution. But then you are in a big company, Intel, which used to be a revolutionary, but now it's becoming more like, big company, much bigger bureaucracy and organizations you have to manage. So how do you thrive in a large company with your startup mentality?
It's a great question. I think the relationship we have with Intel has been very rewarding, and I'll explain why in a moment. But let's take a step back. When you are a subsidiary of a large corporation, you have this kind of sense of security. But I quickly learned that this sense of security could be overrated. You really need to think as a startup. You need to, in order to do something meaningful in life, you have to be hungry. If you're not hungry, you cannot do meaningful things. So you need to be very crisp on your vision. You need to be very efficient in the way you manage your costs, and you should always drive for profitability. These are kind of the tenets of a good startup. So even if you are part of a big corporation, if you want to survive for the long run, you need to continue thinking as a startup. And at the time of the acquisition with Intel understood that in order for this acquisition to succeed, they should keep MobileEye as a subsidiary and not integrated into the big machine. And this has turned out to be very successful. So on one hand, we continued our startup mentality. On the other hand, it was like going into a candy store where we looked at what Intel has that we can start using, and we built a division we called IC. That this division is something that we could not have built as MobileEye alone. It is a division that is taking technologies from Intel, like silicon photonics, like radar technology, and building the next generation LiDARs. These are frequency modulation coherent wave. This is kind of the cutting edge. So this, I think, is an acquisition that should be studied. This is an acquisition that really should be in the mindset of companies that go and acquire other companies. It's a very successful acquisition.
That's really good to hear that. Let's talk a little bit about the where we are with machine learning and AI. Clearly, a lot of AI machine learning has been very effective in solving particular domain, particular applications. And people start talking about this concept of general AI. And I like to, because given your background as a professor and expert in AI at the Jerusalem University, I'd like to get your perspective around where is it going and where are we today and where we're going on this general AI perspective.
Well, actually, we are in the midst of a revolution. Things are moving very fast. So the kinds of AI that we are used to is what you said before is narrow AI, solve particular problems, play chess, play Go. have a perception system for autonomous driving, do decision making for autonomous driving. These are all narrowly defined problems. The new frontier right now is language, natural language understanding. In the past 2 years, new networks have been defined. These are called transformer networks, originally from Google researchers. And this kind of technology is revolution from two perspectives. First perspective, if you can conquer the language frontier, that means you can have a computer that understands language and can write language, then you are getting closer to broad AI. I'll not call this general AI, but much broader AI than the kind of AI that we are today. But more importantly, the techniques of these networks are based on a new way of handling data. It's called self-supervision. Mm-hmm. The classical way of training networks is you take data and you label that data. For example, if I want to recognize cars in an image, I take lots and lots of images, and then I have someone that will put a bounding box around every vehicle, and I'll use that as input for to train a system that will try to recognize cars. And this is a very limiting factor, because then you cannot treat unlimited amount of data, because every data you need to go and label it. The way you train these language models is completely self-supervised. It means that you can build now monster networks that are trained on unlimited amount of data. It's just have enough compute, and you can build something monster in terms of its size. And this self-supervision idea is now transcending back to pattern recognition, back to computer vision. There is now a wave of academic papers, and also industries is heavily looking into it, how to be able to train perception systems that want to do pattern recognition without labeling the data. So this opens up now a new frontier in which you can build a monster network. Take, for example, GPT-3 from OpenAI, 174 billion parameters. This is really a monster network. And what we have seen, what the community has seen, is that these monster networks is kind of a brute force way of doing problem solving. It's not elegant. A scientist of 10 years ago would kind of cringe in thinking that, the way to solve a problem is simply build a monster network. But these networks are surprisingly effective. What GPT-3 has been showing is really remarkable. So I believe that, and by the way, I co-founded a company, AI21 Labs, that is really building these kinds of systems for language understanding. And we recently launched 3 weeks ago a writing tool called WordTune that is really doing magical things with language. I'm personally very, very interested in this field, both in terms of language and what those networks, what those technologies can do outside of language. And I believe that if we simply continue this path, within this decade, we will have broad AI.
That is really an interesting subject that we're going to be watching and observing. But you're very optimistic about where the next step would be, and you think we're in an inflection point, which is very important. Can I just have you have one last question? That is, really, given your background as a professor, entrepreneur, and really running actually very important business at Intel as well, what advice do you give to entrepreneurs?
Well, normally academia and business do not mix. I have been fortunate to be able to hold both ends of the stick in a firm manner, to continue being active and productive scientist, at the same time build meaningful businesses. But I don't have a prescription for it. Regardless, my advice to entrepreneurs is you need to think long. You need to think not 2-3 years away. You need to think 10 years away, 15 years away, and you need to be patient. You need to build a meaningful business. It's something that takes many, many years to build. There are no shortcuts. There are no free lunches. And once you crystallize your vision, make sure that you find good people that will help you to execute, because execution is really the bottleneck. Many people have good ideas. They fail in execution. So find find very, very good people that will help you to execute, and then work on your decision-making skills. Leaders make decisions every day, many, many decisions. A good leader, the number of decisions that a leader would make in a week is comparable to the amount of decisions that a normal person would make through its lifetime. If those pillars are set, then I think the chances of success are much, much higher.
Right. Well, you really have shown that you're a very long-term patient person and built a really great team from 1990s, looking at the vision as a tool and then building a business that now you pioneered around this whole idea of the autonomous, as well as then moving into helping people to live better by using the products like Orcam that are coming out. So very broad, but clearly you've been looking at the same fundamentally what you can do with that technology into impacting society. And that's a long-term journey, wasn't it?
Yeah, long-term is the key.
But thanks a lot. I really appreciate it. And hopefully we can meet in person, but at least we have a chance to talk through Zoom.
Very good. Looking forward for your visit, Young.
Okay, great. Thank you.